Hi, everybody. It's Miss Rose. It's week 26, and this is the final topic that we're going to learn in third quarter of geometry. We're going to learn about trigonometry, which sounds really complicated, but these three words right here, sine, cosine, and tangent, are just vocabulary words. They just mean different kinds of ratios. If we don't overcomplicate this and we just learn the vocabulary, we're going to be in really good shape. So let's get to work. The trigonometry that we're studying is called right triangle trigonometry. So the diagram that we're going to be drawing is always going to be a right triangle. Then when we talk about sine, cosine, and tangent, so notice this looks like sin, but it's actually just a three-letter abbreviation for sine. So make sure you call it sine, not sin. When we talk about sine, cosine, and tangent, I always give you an input. You need to know which angle I'm referring to because we're going to be talking about which leg is opposite the angle. And if we're talking about angle A or we're talking about angle B, the opposite leg means something different. So I like to actually circle the letter in the picture so that I can zero in on angle A. So let's label our three sides of this right triangle. Let's start with the hypotenuse because I think we're all really comfortable with understanding that the hypotenuse is the side opposite the right angle. All right, what we're left with is our two legs. The opposite leg is the one where if I shoot an arrow from angle A, the opposite leg is the one across from it that's not even touching the A. And then the leftover leg, the one that is touching the A, is called the adjacent leg. You might have heard the word adjacent before. You might say something like, my house is adjacent to my next door neighbor's house. Usually means something like next to. All right, let's learn what these vocabulary words mean. Here's the key. All it means is it's just a ratio. It's just a fraction. So if I say, what's the sine of angle A? I'm just looking for you to give me a quick fraction, nothing more than that. So sine always means opposite leg over hypotenuse. I don't want to write all of that, so I'm just going to write O over H. Cosine always just means the ratio of the adjacent leg over the hypotenuse. A over H. And tangent means opposite leg over adjacent leg, O over A. It's actually the sine over the cosine as well. The H's would cancel out and you'd be left with O over A. These are just vocabulary words that you have to memorize. And anytime that you have to memorize something, it's nice to have a tool to help you memorize it. So people made up a word to help you memorize that sine is O over H, etc. It's called so, see the letters, sine, O over H, ka, toa. So you'll hear people talk a lot when they're talking about trig, about SOHCAHTOA. It's a made up word. The problem with it is if I said, how do you spell SOHCAHTOA? How many of you would actually spell it in this way? So to me, this is not good enough. I like to have some sort of a saying so that I remember it. Mr. Millington and I found one. Unfortunately, it's not classroom appropriate. So we changed the words ever so slightly to make it classroom appropriate. So here it is. I think this is really helpful for remembering these vocabulary words. It goes, some old hippie caught another hippie tripping over apples. And if you say that saying, then you'll get this vocabulary right every time. So let's see what this actually looks like in problems where there are numbers. So definitely write down this example. On the top of your paper, the first thing you should do is just write down the SOHCAHTOA thing. Some old hippie caught another hippie tripping over apples. All right, we need to know all three sides of the triangle. Right now we're missing one, so we can do Pythagorean theorem to find it. At some point, hopefully we'll have some of those Pythagorean triples memorized, and there are problems like this. This is a common one. It's going to work out nicely, where if you know your triples, you won't have to do all this work of calculating and doing the Pythagorean theorem. See, I have 64, and when I square root that, I get a nice answer. X is 8. So at some point, if you have some of these memorized, you'll look at it and say, oh, it's just an 8, 15, 17, and you won't have to do any of the work to calculate that missing side, and that'll save you a bunch of time. All right, next thing we should do is look at the problems. We want sine, cosine, and tangent of angle C. I focus in on what the input is. Angle C, that's the angle. All right, let's label the hypotenuse with an H. Let's draw our arrow across to the opposite leg. And then the other remaining side is the adjacent leg. What we've done is the hard part. All we have left is just writing some quick fractions, and those are our final answers. So let's look at our SOHCAHTOA right now. Sine is just O over H. So just take your O number and your H number, make the fraction. Done. That's all that you have to do. That's all that we're looking for. You might be saying, well, what's the point of doing this then? You'll see, I promise. This trig is really useful for finding missing sides and angle measures in triangles. We're not there yet. We just need to learn the concept right now. Cosine A over H. So all you do is you just take the A number and the H number, make a fraction, done. And then finally, tangent. Tripping over apples, O over A. Oh, I think I accidentally erased my O. All right, O number over A number, 8 over 15. Congratulations, you just did trigonometry. So like I said, we'll see the uses later. For now, let's just get this down, labeling the triangles properly and making our fractions. What happens if you don't have a picture? Well, I told you that this is all right triangle trig. So let's just immediately make a picture of a right triangle. It says cosine A, so there's going to be an angle A in there. It doesn't matter which angle, just don't make it the right angle. Make it one of the other ones. So I don't know if this is triangle ABC or something else with an A in it, but that's what I'm going to call it. All right, step 2, write your SOHCAHTOA. Some old hippie caught another hippie tripping over apples. All right, the sine is what is given. Sine, O over H. So all we have to do is say, oh, the 3 is the O number and the 5 is the H number. So we're talking about A. So the O is the leg opposite. So that's 3. And then the hypotenuse is 5. We're not done though. We need to find the missing side. So Pythagorean theorem again, unless you know this triple. This is the most popular one, so it's a good one to know. It's a 3, 4, 5 triangle. But in case we don't know that, let's do the Pythagorean theorem. 25 minus 9 is 16, which is a perfect square. You get 4. See, 3, 4, 5. All right, this is the hard part. The final answer should be quick and easy. It's just asking for our cosine fraction. So cosine, remember, is A over H, adjacent leg over hypotenuse. So I just want the A number and the H number, and I want to make a fraction. So 4 over 5, done. So that had a lot to it. You had to label the triangle, do Pythagorean theorem, and then come up with the fraction for cosine. Something good to know is the sides don't necessarily have to be 3, 4, and 5. They just have to be in that ratio. So it says the sine is 3/5. It might really be 6/10, and it was simplified to 3/5. So that's what the follow-up question's asking. It's saying, what if the sides aren't actually 3, 4, 5? What if the triangle's supposed to have a perimeter of 60? Well, let's find what our perimeter is now. It's 3 plus 4 plus 5, and that adds up to 12. So you could use scale factor. I like to set up a proportion. So I say my triangle right now is 12. The triangle that it actually is 60. So maybe I'll put now and actual. The hypotenuse right now is 5, and it's saying, what's the actual hypotenuse? X. And then we can just do some cross multiplying. 12x equals 300. 300 divided by 12 is 25. So it's not actually a 3, 4, 5 triangle. It's actually a 15, 20, 25 triangle. The ratios are the same, but the side lengths are actually bigger. So thought that was important to point out too. Let's do one more thing and then we'll do some practice. What if instead of giving you the ratio, what if I give you the angle measure? Well, there's very few angles that I can give you right now. It has to be part of our special triangles that we learned about last week. So when I say tangent 45, remember how you have to draw a right triangle? Well, if you have a right triangle with a 45, then it's a 45, 45, 90. So what we learned last week is that's x, root 2. Or I could make up numbers too. I could say like 8 root 2 or something like that. Next, I'm going to write my SOHCAHTOA. Some old hippie caught another hippie tripping over apples. All right, last thing that I have to do is just make my tangent fraction and I'm done. Tan 45 is, well, let's see, tan is O over A. So pick one of your 45s. It doesn't matter which one. This x is opposite it, and this x is adjacent to it. So x over x. Well, those cancel each other out. Anything divided by itself is just 1. So if you were to type tan 45 in a calculator, which we'll show you how to do in a little while, you'd actually get 1 as your answer. All right, final problem is what about a 30? So now we're talking 30, 60, 90. So we learned the short leg's x, the long leg is x root 3, and then you double the short leg to get the hypotenuse. So what is cosine 30? Well, cosine is A over H. So let's take a look at the 30. The adjacent leg is the x root 3. The hypotenuse is the 2x. A over H. So I'm going to go x root 3 over 2x. If I cancel the x's out, I just get root 3 over 2. So if you type cosine 30 into a calculator, you'll get whatever the decimal of root 3 over 2 is. So let's give these problems a try, and then in a little while, you'll see what this trigonometry stuff is really used to do. All right, see you in a minute. Bye.